On the back side of our notes today, we want to go ahead and take a look at what happens when we have a plane or a boat and we have some sort of force working against it. So for example, question number 4 here has an airplane that's heading due north. So if I have my airplane going north and there's some wind that's blowing against it in the direction northeast 60 degrees, it's going to throw it off course a little bit. It's going to now be going slightly to the right, and it's probably going to have to travel faster than its original speed in order to maintain that speed if it's having a wind against it. So what we want to do today is we want to come up with a vector for our airplane, come up with a vector for our wind, and add the two together to get our true velocity and true speed and true direction of our airplane. Well, if we want to find our true velocity, it's made up of two vectors. The first vector is the vector of the airplane, vector v. When we take a look at our vector, sometimes we're given our x component and our y component, our left to right move and our up and down move. Other times we're given our magnitude and our angle. In this case, it's very important to remember that the magnitude is the speed. So on all of these problems, our magnitude, our length, any measurable amount of our vector, is going to be our speed. So in order to do these problems, we need to remember that the magnitude is the speed. All right, so first of all, question number 4 says, an airplane heads due north at 280 miles per hour. It's experiencing a 38 mile per hour crosswind flowing in the direction northeast 60 degrees. So what we have to do is we have to come up with a vector for our airplane and a vector for our wind and add those two together. So let's start off with our vector for our airplane. Our airplane is going north at a speed of 280 miles per hour. So if I'm traveling north, that means I'm making a 90-degree angle there with the x-axis. So if I want to come up with my vector for my airplane, vector v, then I'm going to take my magnitude, my speed, 280, times the cosine of my angle, so the cosine of 90 degrees, and 280 times the sine of my angle, 90 degrees. For the wind, this is the first time that we've seen some direction. For example, in this case, if I'm traveling northeast 60 degrees, that means I'm making a 60-degree angle with the north line. This is the only time that we measure from the north or south line. Other than that, all of our angles are always measured from the positive x-axis. So if I am experiencing a wind of 38 miles per hour flowing northeast 60 degrees, that means that it's making a 60-degree angle with the north line towards the east. Well, if that angle there is 60 degrees, then my angle that I make with the x-axis is 30 degrees. So for part B, if I want to come up with a vector for my wind, then I'm going to take its speed, its magnitude, 38 times the cosine of my angle, 30 degrees, and 38 times the sine of my angle, 30 degrees. Once I have my vectors for my airplane and my wind, to find vector W, it says I want to add my two vectors together. So for part C, if I want to add my two vectors together for vector W, I'm going to start off by adding my x components together. So I can go ahead and take 280 times the cosine of 90 degrees, which is 0, plus I'm going to take 38 times the cosine of 30 degrees, and that's going to give me 32.9. And we can round all these answers to the 10th place if you want to. When you're checking your answers in the back of the book, they'll leave them in radical form because a lot of these angles will be special angles on our unit circle, but feel free to leave them as decimals. Then, for my y component, I want to add my two y's together. So let's take 280 times the sine of 90 degrees, and let's add that to 38 times the sine of 30 degrees, and that's going to give me 299. Now that I have this vector W, I want to go ahead and I want to find its true speed. Well, I know that speed is the magnitude. So I'm going to go ahead and find the magnitude of my vector w. And we know that to find our magnitude, we take the square root of our x component squared, so 32.9 squared, plus our y component squared, 299 squared. And let's see, let's plug that into our calculator. The square root of 32.9 squared plus 299 squared. And I get that in order to overcome this wind, I have to actually be traveling 300.8 miles per hour. For E, now we want the true direction of our airplane. So for part E, let's go ahead and draw in that vector W. So vector W goes forward 32.9, goes up 299, and so I can draw in my vector W here. And if I take a look at my angle theta, I'm going to go ahead and use my tangent of theta is going to be my opposite side, 299, over my adjacent side, 32.4. So we want to use our inverse tangent on 299 divided by 32.4, and that's going to give us 83.8 degrees. So if my angle inside my triangle is 83.8 degrees, I want to find out, well, what angle am I making with the north line? So if I want to find my angle that I'm making here with the north line, I can subtract the 83.8 from 90 degrees, and 90 minus 83.8 gives me an angle of 6.2 degrees. So I'm going to be traveling northeast 6.2 degrees. Let's take a look at this same example again, but with wind blowing a little different direction and our airplane traveling in a little bit different direction. For question number 5 now, we have an airplane who's going to head northeast at 300 miles per hour. When it just says northeast or northwest, southeast or southwest, that means it's cutting that quadrant into 2 equal parts, so it's making a 45-degree angle. So let's start off with our vector for our airplane. Our airplane is going to head northeast at 300 miles per hour. So here's my vector V. It's making a 45-degree angle, and it's traveling at 300 miles per hour. So let's go ahead and find our vector for our airplane. We're going to take our speed, 300, times the cosine of 45 degrees, and our speed, 300, times the sine of 45 degrees. Now let's look at our wind. Our wind is blowing at 40 miles per hour in the direction northwest 15 degrees. So if we take a look at our wind, 40 miles per hour, northwest 15 degrees. So here's my wind, and it's making a 15-degree angle here with the north line towards the west. So if I look at its whole angle in standard position, I'm going to take 90 plus 15, and it's making a 105-degree angle with the x-axis here. So for part B, for my vector for my wind, my vector u, I'm going to take its speed, 40, times the cosine of 105 degrees, and 40 times the sine of 105. Because remember, for our angles, we always want to measure from the positive x-axis. Once I have vector v and u, I want to add those 2 vectors together to get my vector w. So let's add our x components together. Take 300 times the cosine of 45 degrees, and we want to add that to 40 times the cosine of 105 degrees, and that gives us 201.779, so let's go ahead and call that 201.8. Then let's do the same thing. Let's add our y components together. 300 times the sine of 45 degrees plus 40 times the sine of 105 degrees. And that's going to give me 250.769, so 250.8. Once I have my vector w, I want to then go ahead and find its true speed. Speed is magnitude. So let's find the magnitude of vector w. Remember, magnitude is length, and it's the square root of my x component squared plus my y component squared. So we want to take the square root of 201.8 squared plus 250.8 squared. Let me plug that into my calculator. And instead of going 300 miles per hour to overcome this wind, our plane has to go 321.9 miles per hour. To stay on course. Then let's go ahead and figure out what happens to the direction of the airplane when it's being pushed by the wind. So if I redraw my x and y axis, my vector w is forward 201 and up 250. Oops, forward 201, up 250. So I can draw in my vector w. And let's go ahead and find that angle theta inside my triangle. So I'm going to use my tangent because I have my opposite side, 250.8, divided by my adjacent side, 201.8. And again, I have to use my inverse tangent since I'm looking for the angle and I have the ratio of the sides. And that gives me 51.2 degrees. So if we have an angle inside our triangle of 51.2, we want to describe the angle sitting in between the north line and my vector. So if I take 90 minus the 51.2, that's going to be a 38.8 degree angle. So I'm going to be traveling north 38.8 degrees east. I'm being pushed more towards the west.